In a previous video, we looked at how we can take the derivative of our inverse trig functions, and now we're going to look at integrals involving inverse trig functions. So you need to make sure that you kind of change gears because now we're looking at integration. Once again, we're going to let u be a differentiable function of x. Okay, so u is just not representing a variable, but it can be a function of x, and a is going to be some real number that is greater than 0. So if we look at the integral here of du over the square root of a squared minus u squared, if we can get our integrand to match this format, then the integral is simply the arc sine of u over a plus c. So we need to make sure that we identify a, which is a real number squared, and then our u, which is a function of x squared. Now, once we identify a and u, you need to make sure that you have your du. So that means once we find u, we need to take the derivative of u, and du must be in the integral. All right, then if we look at, we have another formula, du over a squared plus u squared. If we can get the integrand to match up to this, then the integral is simply 1 over a arctangent u over a plus c. And if our integrand looks like the third one, du over u multiplied by the square root of u squared minus a squared. Now, once again, notice that here you have u squared minus a squared, but also you have a u out front. So again, once you identify your u, you must have the u squared, the minus a squared, and also, once you identify u, we must have du. And for this one, we would have 1 over a multiplied by the arcsecant absolute value of u divided by a plus c. So let's see if we can find the integral of 3 over the square root of 1 minus 4x squared dx. Now I'm going to maybe pause the video and see if you can determine which one of these integrals we're going to use, or try to set this up to match. All right, so let's see, we have the square root of 1 minus 4x squared. So because we have the square root, it looks like it's going to be either 3 or 1. We don't have anything in front of the square root, so it looks like it's probably going to be number 1. So then we have a squared minus u squared on the bottom, so it looks like we would let a equal 1, because we can think of this as 1 squared. So we can think of this integral as the square root of 1 squared minus, and what are we going to let u equal? Well, if we have 4x squared, we could think of the square root of that, and that would simply be 2x. So we could think of this as 2x quantity squared. So therefore, u is not 4x squared, but u is equal to 2x. And of course, now the part we don't want to forget is we need to find du. Well, we take the derivative of u, which the derivative of 2x is simply 2 dx. Well, we have the dx, but we are missing the 2. Well, we know from before we can certainly just multiply n by the 2, and if we do that, we would have to put a 1/2 out front. Now you'll notice we have this 3, which is just a extra multiplier, so we could simply just pull the 3 out front. So we would have now 3/2 out front. And we have our 2x dx, which is du. And then on the bottom we have our square root of 1 squared, which is our a squared, minus 2x, which is our u squared. So we have du over the square root a squared minus u squared. So at this point, we just simply plug into the formula arc sine of u over a. So here we would have then the 3/2, that's our multiplier out front, times the arc sine of u over a. Well, u is 2x, a is 1, so that's 2x over 1, or simply 2x plus our constant c. So once you set this up and identify a, u, and du, the problem becomes very easy because they already give you the formula, arc sine u over a plus c. Now the tricky part is identifying which formula that you want to use. So here we have the integral of 4 over 1 plus 9x squared. So again, pause the video and see if you can work this one out on your own. All right, so if we look at this one, we don't have a square root. So if we go up here to our formulas, it looks like it's probably going to fit the number 2 formula, du over a squared plus u squared. And let's see if that works. And I'll copy this formula down for us as a reference here. We have the integral of du over a squared plus u squared, and that's going to be equal to 1 over a arctangent of u over a plus c. So looking at this, we're going to say let a equal, looks like 1, and then u is going to be equal to, well, we have 9x squared. So once again here, we could think of this as the integral of 1 squared plus 3x quantity squared. Okay, so 3x squared would be 9x squared. So therefore, it looks like u is going to be 3x. And we take the derivative, then our derivative is going to be 3 dx. Now, we have the dx, but we are missing the 3. So we need to multiply once again by 3, and then a 1/3 out front. And once again, our 4 that we have here, we can certainly just factor that to the front. So we have 4/3 out front. 3 dx is our du, and then we have a plus, or a squared rather, plus u squared. So now it's just a matter of plugging into the formula, so don't forget to bring down our 4/3. And then that's multiplied by 1 over a. Well, a is 1, so that's 1 over 1, so 4/3 times 1 is 4/3. Then we have the arctangent of u over a, so that's 3x over 1, or simply 3x plus c. So once again, once you're able to identify a, u, and du, the integration becomes fairly easy. All right, one last example, and again, try this on your own. I think you'll find this to be somewhat straightforward. All right, once again, I'm going to go ahead and bring down the formula. It looks like this one, again, is going to fit the arctangent because we have no square root here on the bottom. So if I bring down our formula again, we're trying to match up with du over a squared plus u squared. And if that's the case, we're going to end up with 1 over a arctangent of u over a plus c. So we're going to let a equal, well, it looks like 4 plus, so if this is a squared, then the square root of 4 is 2, so a should be equal to 2. And then u is equal to the x minus 3 because that quantity is squared. So we have u equals x minus 3. And then if we take the derivative, it looks like we would simply have 1 dx. And we're fortunate here because we already have 1 dx. So there's our du. The 4, that would be our a squared. And then we have our x minus 3, which is our u squared. So here we already have the formula. We don't have to multiply anything else in. So we simply get 1 over a, which would be 1/2 the arctangent of u over a, which is x minus 3 over 2. And of course, our constant c. So here you have 3 examples of our integrals involving our inverse trig functions. And the next video we'll look at some more examples dealing with your inverse trig functions and integration.